Okay, we are now in the final part of the advanced liquid and solid phase microextraction, and this one is dispersive liquid microextraction. From the name itself, we will be involving something that is dispersive, and the keyword contain liquid microextraction once again. So you can guess that this is like the direct advance of LLE method. Okay, whereby it is only involving solvents. In this case, no hollow fiber involved, and this is totally chemistry. Okay, no physical aid of the apparatus. So DLLME is considered a simple, rapid, cost-effective, and give high recovery as well as high enrichment factor. Why did it call rapid? Because we involve a very fast vortex for mixing. Okay, but before we go into mixing whatsoever, we see on how it is done. Okay. So this is the diagram of the DLLME. Okay, it contains sample. Okay, and then in your sample, we will inject the disperser solvent containing the extractant. Okay, example, if your extractant is for example dodecanol, your disperser solvent is something that can make droplets or cloudy solution out of the extraction. So in this case, you can select either acetonitrile combined with extractant, for example dodecanol. So why dodecanol? Because dodecanol is an alcohol containing 12 carbon, right? Okay, means when it is mixed with ACN, for example ACN, okay, so this ACN, it will be producing millions of droplets. So just like what is shown here. Okay, why this droplet is very important? Because all these droplets will enable the extraction. Means that your analyte inside your sample will go into these millions of droplets, okay, and then extract themselves. So just like SPE, the more sorbent you have means the more surface area, right? The same thing here. The surface area for the extraction is enhanced because of the droplets. Okay, and up to here, the analysis or the extraction only take up to 1 minute. Why? Because we are using vortex. Oh, teruknya, sorry lah It is using vortex. So after 1 minute, what should we do? Okay, we have to make sure that all this droplet over here will be produced in one layer only. Why? Because we want to withdraw this layer out and do GC. So how do we do that? We centrifuge. Because water sample is having density different as compared to the sedimented phase. So after you centrifuge, it will be separated easily. So after it is separated, you can take your syringe, just take out this one and then go towards GC, leaving behind the sample of water. Okay, at the end of this video, I will ask you guys to go and look on the YouTube video and see how exactly it's done. Okay, so same like LLE, selection of extraction solvent as well as dispersive solvent is very important. So in the DLLME method, extraction solvent have to fulfill requirements such as high density than water, okay, so that it will sedimented below. Okay, kita tak nak di atas, kita nak below. Okay, low solubility in water just like LLE, and high extraction capability of target compound. Low volatility. Okay, we don't want to use something like acetone. We don't want to use that because it's really volatile. So example that you can use is dichloromethane, chloroform, carbon disulfide, and carbon tetrachloride. However, these are all very dangerous solvent, but nevertheless, because it is used in microliter, it's not that hazardous as compared to the conventional LLE. So this is for extraction solvent. Okay, now dispersive solvent is very important as well. It must be able to miscible in aqueous sample. Dia mesti very miscible in aqueous satu, extraction solvent pun dia miscible. So the good candidate is acetone, methanol, ethanol, and acetonitrile. So in this case, acetone can be used because it will not be volatilized easily as compared to extraction solvent, which is in very high amount. Okay. So dispersive liquid extraction, it is utilizing fine droplets of the extraction solvent, which also contain analyte. So analyte will go into the extraction solvent, and after extraction, it will be settled at the bottom of test tube, and then we can get and do the analysis. Again, the disadvantage is toxic solvent, but it is microliter size, so it's not that bad. Okay. Importantly, it is very high recovery, just in one try. Okay, in LLE you have to do multiple extraction kan? So multiple extraction just to get around 80%. But for DLLME you get very high recovery, more than 85. Okay, in just one try. So that's why it's very low cost. Okay, because of the less usage of salt. So some application of DLLME method. Okay, this is the example of paper. You can go and have a look. You see the analyte is very much related to organic pollutant, phthalic ester, chlorobenzene, medroxyprogesterone, carbamate pesticide. Okay, so everything here is exists in matrix of water, most of them, except for this one, blood plasma for amitriptyline, which is the antidepressant drugs. You can use this and you can get high recovery. Okay, so again, this is the schematic diagram. So you see the droplets over here, we call it as cloudy state. Then you centrifuge, you get the settled phase over here. So everything is at the bottom, okay? So please watch the DLLME procedure video. I will give you the link after this, and you can see that in that video, the operator is doing the experimental in DLLME. And then before we stop, another derivative of DLLME is that the solid flocculation method means that in this case, the drops is not here. The drop is up there. Okay, so how do you take it out? You can simply take the spatula out and proceed to your analysis. Okay, fine droplets of the extraction solvent which containing analyte float. Okay, it is not sedimented. Due to the low density of the extraction solvent, do we want to go to this route? It's up to you. Okay, if let's say you cannot use high density solvent that will be sedimented here, you should use the SF4 method. However, the SF4 method is not that widely used because the problem of taking out the flocculated droplets here by using this conventional spatula. Okay, so this is the application. You can look on your slides. Okay, same.